This is a method to save Arduino pins. This time, we will learn how to control 8 LEDs using just 3 digital pins on an Arduino. When you use an Arduino, you often run into situations where you run out of pins. Taking the Arduino Uno as an example, it consists of 14 digital pins and 6 analog pins. Let's assume we connect 8 LEDs to the digital pins. The Arduino has consumed 8 pins, leaving only 6 digital pins available. How can we prevent this pin waste? The answer is to use an 8-bit shift register, the representative IC used for this IC. First, let's briefly look at what this IC does. When connected to the Arduino, it performs the function of a shift register. It receives 8-bit data output by the Arduino serially and outputs it in parallel. This is a way to save 8 pins when simply turning on LEDs. This IC has 8 output pins. It also has 3 pins for communication with the Arduino: data, clock, and latch. These 3 pins are key to its function. The data pin receives the data output by the Arduino. The clock pin converts the data received by the data pin to a speed suitable for the IC. The latch pin commands the data to be sent to the output pins. Now, let's build an actual circuit and test it. First, arrange the breadboard, Arduino, and shift register. Then, place the LEDs and 330 ohm registers in order. I will choose 3 digital pins to connect to the shift register. I have selected digital 8, digital 9, and digital 10. Digital 8 is connected to the data pin, digital 9 to the clock pin, and digital 10 to the latch pin. Now that the circuit is complete, we will unload the code we prepared and test it. We added code to make the LEDs blink sequentially, and it is working normally. This is a method to save Arduino pins. Now, let's briefly look at the advantages and disadvantages. First, the advantages. Pin expansion. If you run out of pins, buying a larger Arduino can be expensive, or you might lack space for the circuit. Using an 8-bit shift register allows for the design that considers both cost and space. Second, simple wiring. Since you only need to use 3 digital pins on the Arduino, the wiring itself is not complicated. Next, the disadvantages. First, output current limitation. Shift registers have a limit to their output current, so if you want to drive a motor or use large LEDs, a separate MOSFET may be required. Second, slower speed. While the Arduino outputs their data directly in parallel, the shift register processes data by receiving input serially and then converting it to parallel, so the speed may be slightly slower. In this video, we learned how to control 8 LEDs using 3 Arduino pins with a shift register. If you found the video useful, please subscribe and hit like button. Thank you for watching.